Hey guys, welcome back. Session 25 of Java Full Stack Made Easy. So previous sessions we spoke about collections, list in collection. In this session we'll be talking about the sets in collection. So let's go ahead and understand it without wasting much of the time. So first, when it comes to set, in terms of list, we have already seen an array list and we have seen a vector. Okay, a stack is a child of the vector. We will see that later. So now coming to the set implementation. Sorted set, again, whatever you see in blue is an interface. So TreeSet is a implementation of a sorted set. Now when it comes to set, we will be seeing what is hash set, what is linked hash set, and basically we will see what exactly is set first. So let's go ahead and understand that in details. So let me just close up everything that I have done before except the collections demo. Yeah, anyways, let's call it as, instead of collections demo, let's create a set demo class set demo. I'll include a main file into it. Let's clean it up, and there we go. So I'll be creating a normal set first, the set implementation, and let's create a set implementation, import it from Java util. So I'm going to create a set of integer type, and this is going to be my set. Let's call it as my set or anything that we like. So now I've created a set, and I'll create a set out of a hash set. I can create a, like we have seen in this image, we can create a tree set, or we can create a hash set, or we can create a linked hash set. So I'm creating a hash set first. So hash set, this is optional. We may or may not give a integer here. So hash set is created. I'll add some numbers into this. Let's say my set dot add. So this add method is available here as well. That's because the add method comes from the collection interface, right? So it's available for the list as well as it is available for the set. So I'm going to add some random numbers here. Let's say 40, 50, 60 or anything. 40, 2, 3, 4, 5, 6 numbers I'll add in here. So 40, 60, 30, 20, 10, and maybe 70. So this is what I'm adding in here. So I'll save it, and also I will try to print system.out.println. Let's print a my set. Once again, I'm just printing a set here. You can, if you want to iterate over a set, you can iterate over a set as well by using either the iterator, or you can use an enhance for loop to iterate over a set as well. So let me first save it and first see what is the behavior of a set. So a set, let's save it. As we have seen in a list can contain duplicate elements, and list maintains the order in which the elements are added into it, right? So let's save it and see what is there with the set. So I am running it. Now you can see I have added 40 first and 70 at the end. 40, 60, 30, 20, 10 and 70 was my order in which I have added the elements. Whereas when I see it here, it says 20, 70, 40, 10, 60, 30. So first of all, list is unordered. So it does not maintain the order in which we have added the element. So let me copy this and put it into the repository for you. So let's go ahead and add it here. So this is day 25. Okay, so let's go to this day 25 of Java Full Stack Made Easy. All right, so day 25, demo 1, unordered set. So sets by default, sets are unordered. Okay, now let's go ahead and implement another demo here. Let's try and implement duplicates into set and check what happens. So I've added 10 twice and also add 30 twice. Okay, let's save it and run it and see the duplicates. So do you see 10 and 30 twice in here? No, right? So that tells us that sets are unordered, plus they are what? They are unique. So sets contain unique elements. Any duplicate you want to remove in Java, if suppose somebody has given you some list of numbers, maybe they have given you some numbers and they ask you to remove duplicates, what you just do is you create a set and then add those elements into it, or add all the list elements into a set. Your list will become a unique one. That's a default behavior of a set. So demo 2, unique set. All right. So what I have done is I have added the elements into a set and I have seen whether it is ordered or not. So it is unordered. And we have also added some duplicate elements into a set, and then we have seen whether it contains duplicate or not. So we got to know that it does not contain any duplicates. Okay. So now what if I want to have a list, okay, but I want to sort the list? Can a list be sorted or not? That's my next question, right? So can a set be sorted or not? So what I did was, in all my previous examples, I was using a collections.sort, right? So let's try and use the collections.sort here, because see, the set that I'm creating is of type integer, so there should not be any problem for the sort, right? So when I try and do a collections.sort here, let's say system.out.println, and I'll just call it as after sort, and I try to implement the collections dot sort. The moment I'm trying to implement the collections dot sort, you can see that it says me list implementation, right? It only takes a list as its argument. There's nothing called as set here, right? So it does not take a set as its argument when I'm using a sort method. And if I provide my set, it tells me that the arguments that I have passed are wrong, because sort takes a list, not a set. Okay, so what will I be doing if I have a set and I still want to perform sorting on it? Okay, so either convert your set into a list and then sort it, because sort method takes only a what you say, it takes only list, or else what needs to be done? Okay, so or else if you want unique elements but they have to be sorted, so at that time what you do is, instead of choosing a hash set, what you do is you choose a tree set. Okay, let's import it, tree set. We are done. So when we implement a tree set, let's see what happens. Let's save it and run this piece of code and see the result. So here we go, we have 10, 20, 30, 40, 60 and 70, which means that the set is now sorted. We can even sort the set by implementing a tree set. Okay, tree set is sorted set. Tree set, a sorted set. That means tree set is sorted by default. Okay, so a tree set is sorted set. It is sorted by default itself, right? So let me share you this as well. Let's copy this, put it into the repository. So this is our third example. This is about the tree set. Demo 3, tree set. So each and every implementation, whether it is a set implementation or a list implementation or a map implementation or a queue implementation, what you have to decide is what best suits your requirement. Whether you want unique elements, you want duplicate elements, you want sorted elements, or you want a key value pair, or you want first in first out concept. So based on your requirement, you are going to choose a collection. Collections are ready-made data structure for you. So here is a sorted collection for me, sorted set, which does not contain duplicates, and it is sorted as well. Fine. So similarly, what if I want to sort it in the descending order? So if you remember, we had a collections.sort, and then in the collections.sort we used a reverse order. Similarly, with a tree set, what we can do is, see, if you look at the constructor of a tree set, you can see it takes a comparator as its argument, right? So reverse order just returns a comparator itself. So what I can do is I can simply say collections dot reverse order. So if I do a reverse order, it will be sorted in descending order. So tree set, a set sorted in descending order. Okay, let me copy this as well and put it into the repository and call it as demo 4. Descending order sort in set. Okay, so in this example, like in the two examples that I have discussed, what we have done is we have used a hash set. Okay, and then what I have used is a tree set. You can also use, okay, I'll tell you that. Let me give you an example and then let's discuss that. Suppose for an example, if somebody has already used the hash set, can I make it a tree set? Because let's say somebody has a set. Okay, they have already created. Let's say there is a method that says get elements, okay, or get details or anything. So this get elements, actually they have created a tree set or any hash set or whatever it is. So this, suppose it returns a set. Okay, it returns a set of integer. Okay, get elements, and here we will be returning a my set. Okay, so there is somebody who is already giving me the set, and they have implemented a hash set, not a tree set. Okay, so they already implemented a hash set. They did not implement a tree set for us. I'll keep it as it is. So now that I'm getting the elements from somebody, let's make it static so that it can be called without an object reference. Okay, let's call it as get numbers or something. So they have created this numbers as a hash set. Okay, so when I do a get numbers, I get a set. A set of type integer is what I'm getting, right? So numbers is something which I have got. Okay, when I get the numbers, in this example, because it is just of type integer, I am doing it system.out.println. It's a better approach to follow a enhanced for loop to iterate over all the collection, all the elements of the collection and print it. Okay, but because this is available, I'm using it. So numbers. Now when I print this, you notice that it is because it is a hash set, it is not sorted, right? It's not sorted. What if somebody is giving me a set, a hash set basically, and I want to sort that particular set? Is that possible? Yes, that is also possible. Now how is it possible? Let's see that. So we know that a tree set is something that is sorted one, right? So let's say set of type integer. Let's call it as sorted is equal to, or sorted numbers is equal to new tree set. Now does this tree set take a set as its argument or not, right? So we have to see that. Does this tree set takes a collection as its argument? So let's try and pass the numbers in there, because it takes a collection as its argument. Set is a collection itself, right? So let's pass the numbers there. Yes, it takes it. And lastly, what I do is system.out.println sorted numbers. Let's save it, and this should not be this is a way of implementing tree set in a raw type. So let's remove that warning, and now it is sorted. So I am performing the number system.out.println. Let's call it as after sorting. Let's save it and then run it. So here you go. This was the set which was created for me before. Now this is a tree set. I have converted a hash set into a tree set. In fact, it's not a conversion. What you can say is that you got a set and you just sorted it. How did you sort it? By using a tree set. Okay, so tree set constructor takes the collection as its argument. That means you can pass in the collection there. Collection means what? This collection can be passed. So you can pass the list, you can pass the queue, you can pass the set, because all of them, they implement what? They implement the collection. So you can have a list and then pass it to a tree set. List will be sorted. We generally don't do it with a list. That's because we already know that collections.sort method is there, so we can easily sort that. Anyways, so this is how we can perform sorting when it comes to set. Unique numbers plus sorting if you want, go for a tree set. Or else there is one more way. There are a lot of ways that can be implemented. That is, if suppose you already have a tree set implemented, you don't have this argument, you don't want to pass this argument and all, you have two sets and all. At that time, you can do a tree set dot add all also will work there. There's one more thing called as a sorted numbers dot add all. There are functions, add all collection, that also takes a collection. You add something into, you add the collection into it, that will be sorted. Okay, so either you can use an add all, or if somebody else has already created a tree set for you and you don't have this option, then you can use a tree set and then do a add all there. Fine. So let me add this as well, demo 5. Sorted hash set. Okay, in fact hash sets are not sorted, so what I did was I took a hash set and then hash set in tree set, so that will be more meaningful. We did not convert the hash set to be a sorted one. What we did was that somebody was giving us a hash set, we put it into a tree set and we got it sorted. So it's an indirect way of sorting, we can say, when we did not directly sort a hash set. Now going ahead, so we know that now we have sets like a hash set, and we also have a set like a tree set, wherein the hash set does not contain duplicate, tree set also does not contain duplicates, hash set does not maintain the order, but tree set is sorted one. Okay, that also does not maintain the order, but it is sorted. So if you remember, I told you already, sorting is different, ordering is different. So let us now try and create a set of user defined object and then see can we sort that or not. Okay, so whenever we talk about sorting and a set, always go for a tree set, always. Fine. So if this hash set, in this example also you can do this one also, like if this, what if the set was of type player? Okay, it is possible, the set can be of type player, and instead of this my set dot add, so let's call it as players. This is of type player. Hash set of type player is what I have. So user defined object, return players. Let's call it as get players. More meaningful name. Okay, and let's add the details into the players. So what I'll do is I'll go back to my repository day 24. There I have already added players, so I'll copy it from there so that it saves time for me. So day 24, I've created a player using comparable, then sorted player, comparator as well. So I am looking for only the players that I have added. Okay, so here we go. We created this 5 players. I just want this. Copy. Let's go back to our day 25 itself. Okay, so this is our day 25. So I come back here and I add the same 5 players. Okay, objects created, then players dot add. Yeah, I should have copied that as well. Anyways, players dot add in any order you add it, right? Because set does not maintain the order. Player 5, 4, 3, 2, 1. All good. Let's save it. And now I'm creating a hash set of player user defined object. Looks good. Now the moment if I try and do this, get numbers will fail. Let's remove everything that we have done in the previous example. Let's remove it. And now I'll do a get players. Okay, that is going to return me a set, right? So let's do a set of type player is what it is returning me. Players is equal to. So now let's try and print it. System.out.println players and see what is there in it. So we got the players. Fine. So a better way, as I told you, instead of doing all this, go for a enhance for loop or iteration player p of players, and then do a system.out.println p, all the players will be printed. Now let's run it, and there you go, we have the players. What if I create this player of tree set now, because I want to sort it now the players are not sorted at all, right? And the player class does not implement a comparable. It's neither sorted on an ascending order or descending order, right? It's unordered. It's descending order based on the jersey number. Now I have not implemented that. It's already decided that. So what if I want to perform something like an ascending order or a descending order based on the name or based on the jersey number or something? What can I do for that? Okay, so let's try and put this set into a tree set and see what happens. So you have a tree set. Directly I'm creating instance. Generally this is how it is created, because if you want to use only set specific methods, you can create it like this. If you want a tree methods, then you can do it like that. Okay, so tree of type player, sorted players is what I want, is equal to new tree set, and you can add a collection into it. So I'm passing a collection into it. Done. Let's now see what happens if I do this. Let's save it and run and sort the sorted players. Sorted players. Let me check if I have a comparable on the player class. There's no comparable on the player class. Looks good. Now let's run this. So now it says class cast exception. Class player cannot be cast to Java comparable. In the sort method, it was giving us an error directly, saying that the argument of type only comparable is accepted there. But here it says it cannot find the comparable. That means for this particular argument that we are passing the players, it does not implement comparable. So because it does not implement the comparable, tree sort cannot sort it, right? Tree sort will not be able to sort it. So this gives you an exception. If you are creating a tree set out of a user defined object that does not implement a comparable, in that case you get a class cast exception. So creating a tree set out of an object that does not implement the comparable gives you a class cast exception. Now what needs to be done? If you still want to create a tree set out of a class that does not implement comparable, then because we already know that tree set requires what? What does a tree set require? A tree set needs the comparator, so that it can sort it based on the logic that you have given. So players, let's see. Now again, you see that there is a collection argument only provided here. So like a sort takes a collection and then it takes a ordering as well, right? So do we have any constructor implemented that way? You can see it here. So do we have anything like that? Anything like that? There's nothing, right? Nothing like that. So what I can do now is that I can say if I see this tree set, you can see it takes a comparator, player. Tree set takes a collection or takes a comparator, or it takes a sorted set as its argument. Okay, so what I can now do is either it takes a comparator or takes a collection. So I will give a comparator to it. I'll not give it a collection. So I'll give a comparator. What comparator? New. Sorry, I want to give it a comparator. I already have created comparators for player, right? So I'll use the same old thing, same old comparators. New player name sort or something I created. Yeah, player jersey number sort. Let's go for player name sort. And then for this tree set, which is a sorted one, so I'll just say sorted player dot add all. Which collection? Players collection. So that's what I'm adding now. Okay, let's save it and see whether it will be sorted based on the name or not. So now you can see the players are sorted based on the name. So this way we can even sort the sets based on the user defined objects. Okay, so this is how you can do these things. Fine. So in this example we have seen a user defined object being sorted by using a tree set. So in our next session we will be talking about another type of set, that is linked hash set. So see you in the next video.